linkage project is about. And we're really looking forward to learn from you, because I just heard that, collectively, you guys probably have more than 35 years of experience working on EV, and whereas we are just starting the project. So before further ado, I'd like to introduce the three speakers today. The first one is Gil Tal, who's Associate Adjunct Professor and also a Director of the Electric Vehicle Research Center and Sustainable Transportation Energy Pathways Program, and also Research Director of the China Center for Energy and Transportation. And our next speaker is Alan Jen, who is the Assistant Professor in the Civil and Environmental Engineering Department at UC Davis, and a researcher at the Electric Vehicle Research Center. And our third speaker is Scott Hartman, who is the Associate Research Fellow and Assistant Director of the Electric Vehicle Research Center in the Institute of Transportation Studies, again at the UC Davis. So, here.
Thank you. Thank you for the warm introduction, and thank you for having us here. Yeah, I'm the director of the Electric Vehicle Research Center, and that's kind of what brought us here. And I will talk a little bit about who we are and what we are doing. It's not that common that a couple of professors and people from state agencies are traveling to the other side of the world, but we really like doing it. That's kind of part of our DNA to do applied work and to work with the government, with the decision makers that can actually implement it later. And that's what actually brought us here, because Australia is on the verge of change, we hope, and we are hoping to help with that. So our research center is a couple of years old, 2007, when the new EVs were just starting to come back. And we work on everything that is policy, behavior, energy modeling, almost everything that, other than the part of designing batteries and so on. I think what's unique about this group is that we have a critical mass. We have 40 people right now working for us, most of them doing full-time on electric transportation. These are the researchers. We have, it said 14 graduate students. I think that we have 16 full-time programmers, and very, very wide, from everything from anthropology to machine learning and everything in between. And we work as a team. No one works alone. So it's a very fun place to say. I will put a plug here. We are always looking for postdocs, visiting fellows, and so on. We like to collaborate. And the other thing unique is that we 100% kind of soft money institute, and we work for clients. We work for we do applied work. Our bread and butter is the state of California and the federal government. That's most of our projects are. But we also work with companies like Uber and Lyft, with energy companies, with most of the car companies. You will not find Tesla here. They already have all the answers. They don't need academia. The guys that don't want to work with anyone else. And that keep us honest, because they see our work while doing it. And if we're doing something that is just not meeting reality, they will tell us, which is really important for our work. So let's talk a little bit. EVs, you all know, it used to be non-exist, then exist, now it's booming. Now it's happening. China is the main thing, but it's happening all over the world, and it's happening fast. And if our research here was how to make the first early buyer buying their first EV, our research today here is how to make sure that the last one is buying an EV, going to 100%. So today we will talk a little bit about that. And since we have 3 different presentations, we will not go deep to any of our studies. So California is at the 20+%, 25%. This is a couple of months old. The US, it's only here about 8%. Australia, I don't know, but you guys here are about 20-something% right now. So it's really nice. And Australia is somewhere really low there. A lot of these things are happening because of policy, nothing else. It's not just about market, it's about policy. From Thailand and USA to Norway, it's about policy. So we need to kind of figure out how to do it. And in California, it's very easy. Our friends from the CARB, California Air Resource Board, regulate. It's the law of the land that we have to get to 100% market share or sales by 2035. So California will be by 2035 on 100%. What does it mean for the size of the fleet? We probably will be at about 35 to 40% of the fleet will be electric by then. It's a slow transition. Other states that are coming and following California will be much lower, much below, waiting for us to get there. So if before we were trying to see who will buy electric cars, now we are looking at everyone have to. How is that going to happen? It's a very different question. It's not how to convince people to buy one. If everyone has to, how is it going to happen? So I'm sorry that we kind of don't see the head, but what we see here is in 2033, I believe it's 2033. Thank you. Is it 20? Yeah, 2033, 10 years from now. California will have about a third of the cars will be electric already, the fleet, the cars on the road. Other states will be at 6% of the cars on the road electric. The reason for that is California regulated the supply. The ZEV mandate or the Advanced Clean Car 2 mandate forced the OEM, the car companies, to sell X% of their vehicles electric. By 2035, 100%. Well, we are saying 100%, but just between me and you, 80% BEVs and up to 20% plug-in hybrid. That's what we call 100%, which is good. We allow some kind of buffer if we will have problem with infrastructure and so on. So how do we get to these high numbers? We used to study market by doing stated preference studies. And that was our regular, will you buy it under this and that conditions and so on? That's probably not the right tool for going to 100. So we tried something a little bit different. We did a big survey, 1,600 households with EVs that have multi-vehicles, another 3,000 single vehicle. And we use latent class modeling. It's a tool to create clusters to figure out who belong to which group of the EV buyers. So on the right side, we have this multi-EV household, on the left, the single EV or single car household, sorry. And as expected, the biggest group is high-income families who like big vehicles, SUVs and so on. And these are the cars, also the households that buy a lot of new cars in general. Then we have the middle income, younger, more renters. They like the new technology. Then the middle high income, but older family, the empty nesters, they can afford the new technology. And I'm only giving you just a little bit about them, but we have a big list about each one of these groups. So we have here different groups, and we were looking at how they start buying EVs and trying to think about how they will get to 100%. So I'm just showing 6 of the groups here. And think about it, this is the number of cars in California owned by each one of these groups. So the group at the top, these are the single family with income between 75 to 200,000. They own 9 million cars in California. So when we will get to 100%, we need to get them 9 million cars. Today, they are not the high owner of EVs. They're actually the second highest group because they are still slow. The highest group of EV owners are single family with income of more than 200,000. This is the blue one here. But when this group will get to 100%, there are only 3 million cars owned by this group. So we're looking group by group how many cars they own, where they are today, and how they will get there. The secret sauce that is not showing on this slide is that these people here that will buy it later, people who live in apartments, multi-unit, low income and so on, they will buy their cars used, not new. And the only way that we will get there is if these people will keep buying more and more electric car and sell it after a couple of years. So in order for this transition to happen, this group that is small one need to not buy 3.2 million cars by 2045. They actually need to already be at about 8 million cars that they bought and sell by then, or 9 million cars. That's the secret behind it. So if we kind of put it all together, and let me make sure that we have all the pieces, is that, as usual, one too many. We are moving to households that have more than one EV and use EVs pretty fast. At the same time, we have a challenge, and our friends here from the California Energy Commission have a challenge that we are moving from the people who can charge right now with no problem to households that need to upgrade their home charging or cannot charge at home or need to charge 2 or 3 vehicles. So the challenges are changing, the market is changing, and we trying to map it from now to 100%. And I will end with kind of a surprise, I think, to many of our policymakers in California. These are these are pictures that I was taking on my way to work, which is a 5-minute bike commute. I'm biking to work, that's cleaner. And in California today, households who buy their second EV or their third EV, second EV plus, buying more electric vehicles than people who live in apartments. So the growing market is these high-income households who buy many cars, and we hope that will turn over many cars in recent years. So in order to have a good transition, we need to make sure that they will keep buying them, keep selling them, so everyone else will be able to get there. And I will stop here, and we will go and look at, yes, I know, Alan is laughing because these two are really have many electric cars. This is a fake. This is Alan Gen car, and this is behind is mine. That's a good picture. So what? Thank you.
Thank you.
Okay, good afternoon, everyone. So I was sort of trying to think about what research I would present from like all the portfolio of research that we're doing that would kind of be relevant for Australia and people, stakeholders in the transition to electric vehicles in Australia to sort of think about. I landed on this project. So this is some research from one of my graduate students, Kelly Hoogland, where she's asking like quite a specific question, like what is the role of infrastructure, not in the transition, but specifically in engaging people, car buyers, to buy an electric vehicle. So if you look at EV data, you'll see this kind of trend quite a lot. On the left, we have the growth in infrastructure deployment in the United States, and you can see it's rapidly increasing. On the right, we have the growth of electric vehicle sales in the United States. And again, you can see that's rapidly increasing as well. And people often connect these two things together. Clearly, there's a relationship there. However, it doesn't necessarily mean that one thing is causing the other. Some people will often sort of talk about this in a way to say that this infrastructure is causing these sales. However, it's not that simple. It could be equally possible that these sales are causing the growth in infrastructure because infrastructure providers want to make money. They want to deploy their chargers in areas where people already have electric vehicles. So it's not quite that simple. However, a lot of people would have you believe it's that simple. So there's a lot of research out there that you look at or reports, and they will connect these two things together very directly. So I just pulled a couple of examples. One from the chief economist's office in the World Bank, where he says, if you build it, meaning infrastructure, they will come, meaning buyers. So that's a pretty strong assumption there. And the second is a couple of nights ago, I asked ChatGPT, does more electric vehicle charging cause more electric vehicle sales? And of course it said yes. An increase in the availability of electric vehicle charging tends to lead to higher EV sales. And it also named it the charging infrastructure effect, which is a term me, Gil, Alan had never heard. So in any case, like it's becoming an assumption people make. People talk about it this way, but we have to be a little bit more cautious. So most of the research actually that's published on this relationship is only correlational. So it's detecting a significant relationship between these two things, but it can't account for the fact that one thing is causing the other. The issue is it's very difficult to detect a causal relationship. You have to meet these 4 requirements. The first one is a significant relationship. Most studies find a significant relationship. That's not too difficult. Second is a logical explanation. I think we can come up with a logical explanation for why that would be. But where things sort of fall apart is a lot of papers can't account for the fact that these sales could be caused by something else. And they also can't account for this sort of time precedence. It's very difficult to account for the fact that like you put a charger there and then someone bought a car over there, because these things are sort of happening like simultaneously. We found 2 studies though that do meet these requirements, and they also find a significant causal relationship, but only 2 studies. And there's a huge number of studies out there. We found more studies that use these methods and found no relationship at all. And second thing I would say is there's a lot at stake here. Literally tons of money is being invested in infrastructure. The US federal government is spending $5 billion. California's previously committed $1 billion. They committed another $3 billion last year. The California Public Utilities Commission has authorized the state electricity providers to spend a bunch of money. Electro America, which was founded by Volkswagen as part of their settlement for their diesel emissions scandal, they're also spending money. So I think if one of the goals of this is to increase sales, I think it's a question we should be asking and looking into it. And so that's what we did. So we have 2 sort of key questions. First of all, does more electric vehicle charging infrastructure mean people see more infrastructure? With the assumption there being people have got to see it before it has this impact on sales. And then the second thing being, does more electric vehicle infrastructure mean that more people sort of start to consider buying an electric vehicle or indeed buy one? And then the final question is, when people see infrastructure, does that cause them to start considering buying an electric vehicle to a higher degree? And the way we do that is with a survey, a representative survey of 3,000 households in California, where we ask them a bunch of different questions. So the graph at the bottom is where we ask them, have you seen any charges? And they can say, no, I've not seen any, or I'm not really sure, which is effectively no. I've seen them at one place, a few places, or several places. We also ask people if they've thought about buying an electric vehicle. And then we ask people about their awareness of electric vehicles, different like EV programs. We also test people's knowledge. So we ask them, can you name an electric vehicle? And then we score them. And then we also ask people if they can identify how an electric vehicle is refueled, and then again, we can score that. Then we also record their perceptions of EVs, like if they think they're good or bad, or about their different attributes, charging, and so on. We have the demographics. And then we also know where everybody who took the survey lives and where they work. And so we can use that to determine how many electric vehicle chargers are in these sort of home and work locations, and also how many electric vehicles in those areas. So we take all that data, or Kelly does, the student, and she does a structural equation model. And I won't like go into all of this today, partly because I struggle to understand it. But in any case, it's effectively testing the indirect and direct effects of public charging, if there, on if people see public charging and if people consider buying an electric vehicle. And the single-headed arrows are a relationship between an independent variable and a dependent variable, and then the double-headed arrows are like covariances. And I just want to like focus on what our key findings are. What are our takeaways from this like modeling exercise? So first thing to say is there is no relationship between the density of charging infrastructure and if people see it. So just because there's more chargers, we're not seeing more people saying that they're seeing more chargers. And then second, we don't see any relationship between the density of charging where people live and work and if people have considered buying an electric vehicle. And then finally, we also don't see any relationship between that infrastructure and if people have positive or negative assessments of electric vehicles. And then we also don't see any relationship between if someone sees a charger and if they consider buying an electric vehicle. So just seeing charging doesn't mean you start considering an electric vehicle on the whole. However, there is an indirect effect. So if people have positive assessments of electric vehicles, if they have good knowledge of them, essentially if they're already engaged, if they see infrastructure, that does relate to them having a high level of consideration. So if you're already engaged, it does have an effect, but not for the majority of people who are not engaged. Okay, this is just a breakdown of the different results related to these like two independent variables. It basically just reflects everything I just said. So if you just look at the right column, this is people who are seeing charging. you can see that if you see charging, it's related to, having already seen advertising, knowing about incentives, knowing how to name an electric vehicle, knowing how to refuel an electric vehicle. So those are sort of measures of engagement. People who are engaged, they're the ones that see it. If you're not engaged, you don't see it. And so on. I think I'll skip ahead of the time. I'll skip ahead and just sort of give what I think is like the takeaways from this research. So first of all, there's no published evidence that infrastructure causes sales. I think that's becoming more clear from the literature. And then we also don't find any evidence that if you have more infrastructure, more people see more infrastructure, or more people see, or more people consider buying an electric vehicle, or that it improves people's assessments of electric vehicles, unless, of course, people are already engaged. So for that small group of people who are thinking about buying an electric vehicle, that they can name one, and so on, then it does have an effect. And I think this makes sense, right? Like the sort of environments that we drive around in are relatively cluttered. People who are not thinking about electric vehicles, who are not interested in them, they're not going to see a charger because they don't know what to look for. Like, why would they notice it, right? They've got a lot of other things that they're more interested in looking at, probably. So just having it there, people aren't going to see it unless they want to. And then even if someone happens to see one and they're not interested in an electric vehicle, why would that make them think about buying one? Like if someone doesn't own a gas car and they walk past a gas station and they see it like, oh, I should buy a gas car. Like that's not how it works, right? You have to already be engaged. Okay, and what do we conclude? So first thing is contrary to everything I said, we do need charging infrastructure. Like clearly it's a very important part of this transition. We need it for people who don't have charging from home. We need it for people who can't afford a home charger, people who want to take long trips, someone who forgot to charge overnight and needs to top up. Like there's a lot of reasons why we need it, but we shouldn't think about it as like a broad engagement strategy. I think we have to do more than just build charging to get more people interested in this transition. And I think that's especially true in places like California, the US, Australia. In those places, it's very convenient, relatively affordable to own an electric vehicle. They're sort of like supportive environments for owning a car. In places like Norway, it is not supportive at all for owning a car. And there's a lot of push away from gas cars to electric vehicles, and that's something we don't have. So I think we have to think more, we're not going to have those push factors because people aren't going to increase gas price. They're not going to have registration fees based on emissions and so on. And so without those things, we've got to think about like, how do we more proactively engage people? And I think that's kind of like the takeaway here. And if you look at sort of state spending, I think there is a little bit more than $2.5 million on engagement, but that was just a quick search. But the difference in the amount of money that's spent on things like infrastructure compared to engaging people is hugely different. And I think thinking about addressing the engagement problem is also something we should all be thinking about. Okay, I'll leave it there. So this is kind of like ongoing work. We just submitted it to a journal, but there's like an older version of the report there that kind of reflects most of the things I've said. So feel free to read that. And a lot of the work was done by Kelly. So if anyone has questions, feel free to direct them to her. Yeah, thank you. And I'll hand over to Al.
All right, hello everyone. So like Scott, I was kind of searching for some topic that I think would be sort of fundamentally interesting to folks who are trying to get to this 100% electric vehicles. And so I actually switched my presentation. One of the things motivating this was in conversations with a lot of the government officials, both in Sydney and here. And actually one of the most common questions that I receive that maybe you guys have heard is the grid ready for electric vehicles? And so this research here is hoping to address that. So I wanted to give a little bit of background for folks who are maybe a little bit less familiar with the grid system. So it's basically comprises of three major parts. So one is your generation. Two is your transmission, which is how you get your electricity super long distances from your generation to your sort of end population centers. And the last one is essentially your distribution. Those are like all the sort of localized infrastructure that's getting from substations down to your local businesses and your houses and that sort of thing. Okay, and so when you guys hear about electric vehicles and the grid, you may have heard about these really interesting potential opportunities, right? Things like if you charge them at the right time, you can have lower emissions. We can do things like renewable integration. In certain areas like California, we have this like duck curve thing, right? Which is this phenomenon that happens when you have lots of solar and then all of a sudden it goes dark and you have to ramp up all these power plants. And so you may also have heard that electric vehicles can, help reduce some of the negative effects of having a system like that. But actually, what we're looking at today is not connected to any of that. And I think there's actually a sort of less sexy, but more sort of fundamental issue when thinking about integrating these vehicles. And that's really on the sort of localized distribution side. So we don't really think about the generation side of things in this question. Okay, I'm not going to spend too much time here on the methods, but suffice to say, one of the challenges of doing this kind of work is that you need to be pretty knowledgeable about what's going on in the grid, but you also need to know a lot about what's happening sort of on the electric vehicle side of things. And so, the sort of specialty that we're offering from this research center is trying to integrate as much realism into both of these aspects as possible. So I'll talk a little bit about some of the data sources here. So on the grid side, when we're thinking about the distribution network, we actually have convenient access to what's known as the integration capacity analysis maps. So this is something that our Public Utilities Commission required utilities in California to publish. And originally, the idea behind this was for local distributed energy resource developers, like if you want to put like solar on your rooftops, this was a way for those developers to get an understanding of what areas kind of make the most sense to install those resources. And so it is fairly high resolution. Okay, so these are 3 of the largest utilities in California, and just to give you a sense of kind of the scale that we're talking about here. So PG&E, that's kind of like the Bay Area. You think of San Francisco and the greater areas surrounding that. SDG&E is for San Diego, and then Southern California Edison is the greater Los Angeles area. And these lines represent what are known as distribution feeder circuits. And when you see lines in red or yellow, it's an indication of essentially how much capacity is left in those lines. So we can look at historical data and see how everyone's using their air conditioning and their TVs and their fridge and all of that, and get a sense of how much of that load the hardware can support. And so from there, you can essentially add in electric vehicle load to get an understanding of, oh, this particular block right here is going to be particularly problematic. And in order to do that, you also need to know where are those electric vehicles going to be located, how many in this year and in the next year and in the next year. And then you also have to know where are they charging? When are they charging? How fast are they charging? Right. And so all of these questions pull in a substantial amount of modeling, both from the way that they're traveling and the locations that they're traveling, how fast they're going, and then essentially where that adoption is happening throughout the state. And so we are really kind of zooming into fairly high resolution in order to get answer to those questions. Yeah, and then patterns of the charging based off of, are you charging at home, if you're charging in public, if you're charging at work, and how fast that's happening. Okay, and so jumping kind of straight to the punchline of this work. So in 2025, this is a map of California. We've zoomed all the way out, and all these little squiggly lines that you see everywhere, those are essentially zoomed out pictures of our feeder networks. And so what you can see here, most of it is in blue, which is good. That's what we want. It means that there are no what we call overload conditions. In other words, that the grid is not essentially getting stressed that much. There are actually some circuits that you can see in this map, which are green. Those are baseload overloads, which means even in the absence of electric vehicles, those guys are probably going to be problematic, and utilities are going to need to upgrade some of their hardware in the near future in order to accommodate the loads that are happening in those areas. And then in red, these are local feeder circuits that are getting overloaded specifically because of electric vehicles. And so doesn't look too bad in 2025, but as you can see in 2045, the vast majority of our electricity infrastructure is going to need to be upgraded at that distribution level. So it's not to say that utilities aren't thinking about this, right? And that there aren't sort of planned upgrades. However, when we look at some of their analysis that they've done, they have these projections through what's known as grid needs assessments. There's actually a fairly large mismatch between our analysis and the work that they've done. And I would say they're a little bit more pessimistic and a little slower on the uptake and keeping up with some of the more aggressive numbers, especially with new regulations that are happening constantly. Their analysis is definitely sort of lacking. And so we estimate when thinking about the upgrades that will already happen, you're still going to see half of all feeders are going to be overloaded because of electric vehicles by 2035, and 2/3 of those feeders will be overloaded by 2045. We also have measurements of the intensity of the overload, and so it actually does make kind of a difference if you have these big spikes that are going over some capacity threshold. Even if you're not reaching what we call kind of the voltage threshold, which would be like tripping out a transformer, you can have issues where if you're over like a thermal limit, let's say I've installed a transformer that's meant to last 15 years, as you go over that limit, where a lot of people are charging at night, for example, traditionally during times where these transformers would be cooling down, the lifetime of that hardware may go down from 15 years to like 2 or 3 years, right? And so these types of issues will still lead to accelerated degradation and sort of large costs. Yeah, and so in terms of severe overloading, we kind of measure that by the redness over here. And so certainly the sort of dark red areas are going to mean probably a more pressing need for upgrades. Yeah, there are unfortunately there isn't like a generalized solution to this. Unlike a lot of the grid integration topics that you may have heard around like renewable integration, for distribution infrastructure, we find a lot of sort of heterogeneity or differences in different locations for how it's problematic. And so there are certain feeders that are especially dominated by home charging. There are some feeders where a lot of the overloading is dominated by public charging. And so you're not really going to find a one-size-fits-all solution to these types of issues. Now, this analysis doesn't get into some of the potentials like smart charging and B2G, but we can observe sort of at a high resolution at individual feeders where that might come into play, right? And so if I kind of look at some of these plots, which are showing kind of the load shapes, the dotted line here shows essentially the amount of space you have to work with at any given time of the day. And so if you could somehow, shift some of that load to be more under that dotted line, then you could help avoid, for example, needing to install larger capacity hardware and avoid some of those installation costs. And so I think that there is sort of potential, both from a research perspective, but also from an application perspective, to really start thinking about addressing some of these issues in the future. In this particular work, we've actually gone a little bit farther than what I have in the slides. We actually do have cost outlooks for a lot of the upgrades that I'm showing in this work. And so in California, we anticipate over the next decade on the order of $50 to $60 billion required in distribution level upgrades. And that is a sort of a very substantive amount of money, especially when thinking about relatively how much money is spent on the distribution infrastructure. And that also leads to a lot of other sort of interesting research questions in the future, and also has implications on equity, for example. One of the issues that we're starting to think of about a little bit more is, suppose that you are a rich person who buys a Tesla in San Jose, right? And you charge your vehicle, and it requires an upgrade of a transformer in your neighborhood, but the cost of that hardware to upgrade gets rate-based out to everyone in PG&E. So my electricity bill is going to be going up even if I don't own an electric vehicle. And so a lot of that sort of cost implications and equities is, I think, becoming, it's kind of coming to the forefront as we think about the implications of installing and upgrading all of this hardware. Yeah, and I think that's it for this, but happy to take any questions. And yeah, Yanning, one of my students who worked a lot on this project, she's would also be a contact if you have specific questions for this research.
Thanks so much.
Maybe a second before we start the question, we have colleagues from the California Resource Board. They answered some of the questions better than us. So maybe quickly introduce yourself, and we can try and think you if you are the guy.
Good idea. My name is Sydney Burgess. I'm the Deputy Executive Officer at California Resource Board. So I oversee medium, heavy duty, light duty regulations, off-road regulations, and most of our programs.
Mike Curry with California Resource Board. I assess light duty vehicles and all. So I already yes, fantastic.
You talk about the impact on the usage on the grid. If you actually also taking into account, say, external factors that may impact on the grid system, I'm thinking in terms of severe weather or other impacts that will take out the grid, and how would that impact on the usage?
Yeah, so from a resiliency perspective, certainly in California in particular, they're faced with some of these interesting problems, especially recently with some of the large wildfires. And so at the same time that utilities are having to deal with this type of issue, they are having to think about ways of handling, additional resiliency that's popped up over the last couple of years. And I think there's kind of a particularly interesting thing that's been happening where utilities are being found liable sort of no matter what the situation is. And that's led them to be a lot more conservative. We have these, public safety power shutoff. I think that's what it stands for, PSPS events, where the utilities just turn off power to a bunch of people in anticipation of any, potential risk that's happening in terms of disasters that they may be held liable for. And so that's one of the consequences of the recent events that have been happening.
And Frank, and Lee, and
Can you talk at all about time of day pricing for electricity? I imagine the combination of a lot of people charging their EVs overnight, plus the fact that here in Canada, nighttime electricity is much more carbon intensive.
Yeah.
And so basically, if you're trying to save on infrastructure and reduce emissions, there's very much stronger case for time of day pricing.
Yes. However, unfortunately, the time of use pricing again is really meant as a way to reflect prices at the sort of wholesale generation level. And so those time of use prices would be good for doing things like emissions balancing or renewables integration, that sort of thing. But at the distribution level, the situations are so specific that time of use pricing is not going to really help you here. And the issue, right, is not low prices when solar, high prices when you're using other generation. It may be more that like this block right here, this neighborhood needs low prices at this time because their transformer is being stressed out by some commercial AC, and then right across the street you have to price differently in order to handle the localized infrastructure there. And the reason why I think this is a really difficult problem to solve with pricing is that's just like not allowed. The PUC doesn't allow for it's and I wouldn't even say not allowed. It's kind of unprecedented to have such localized level pricing, and it would lead to a lot of like other types of issues as well.
And all of our research and experiments in California show very low elasticity. So people are not changing their behavior if you change the price of the electricity, as we hope they will. We have time of use in California, and we are trying to move people to daytime because of solar and so on. And it's just not doing the job as we hope it will do. You need to change the price much higher than what we can actually do.
You kind of hinted that you might have looked at this on the last presentation slide, but it seems to me that you've got a map where the overlooks places that you would want to put in local small scale solar with battery to be able to do localized power generation, save it, and then have it available without even having to stress transformers outside of the energy.
Yeah, so that's something that we're trying to integrate into this analysis, including upgrades in like efficiency, adoption of distributed energy resources, just to make sure that we are not just following along what the utility is saying, but thinking about what the sort of best research is saying about the deployment of some of those technologies. When we couple this work with deployment of those types of resources, I think that in some places you may see shifts in like whether or not you are reaching overload conditions and that sort of thing. But generally speaking, I think that most of the trends that we see here are still gonna be there. That we'll still see lots of overloading.
Yeah, I'm from the Electric Vehicle Association representing the owners and drivers. I'm a bit dismayed by what you just said about the projected overloads in 2045. We've looked at this issue in our organisation. First of all, we think there's a role for community education, just educating people. Do not charge your EV between 5 and 8 million. We also think there's room for tariffs, but also in residential apartment buildings where we've just introduced a new national construction code requiring 100% of parking spaces in residential apartment buildings to be EV ready. We have a model that the charges will simply not turn on until 11 o'clock at night. You know, and so there'll be smart charging and all those new, not the existing ones, the new residential apartment buildings, more or less to enforce sensible time of day charging. I don't know whether any of those could apply to California, possibly not. But, you know, to me, this is a really big issue.
Everything you said is exactly what we need to do and we are doing. But when all the cars in these small cul-de-sacs are electric, 2045, you need to think about the next step. So we are trying to look ahead when it will be more than what's happening right now. So everything you said are the tools that need to be implemented today. And then think about what will happen.
Right. Yeah.
down the road. Yeah.
If I were to back up for a second and talk a little bit more generally about this work, this isn't to say that like, oh, we shouldn't be electrifying or we can't really do it. This, you know, in my mind, this is more of like a heads up to utilities who are, we think, doing some of these projections inaccurately and saying, hey, you need to watch out and start thinking pretty hard about some of the infrastructure rollout.
It looks like on some of your graphs, the ST and San Diego Gas and Electric wasn't going to overload as much or as early as some of the other areas. I'm looking at this graph, right? But my question is, if that is the case, that SDG isn't overloading as much, what's driving that? Is it just a newer grid? Is it a smaller grid, and that's why it's a smaller amount of upgrades needed? That's a good question.
Let's see. I don't know if I would characterize it, but not quite like that. I mean, there's definitely some areas, but actually, you know, some places it looks there. It actually, to me, the relative amount of green there kind of indicates that San Diego's grids are already kind of in trouble, and they need they already need upgrades even without the EVs. Yeah, but I mean, generally speaking, the presence of blue lines anywhere in sort of in the later map is an indication that one, either you've already got lots of capacity there that can handle the EV load, or two, there's not much charging demand happening in that particular area.
And in California, we are having a strong push out of natural gas at homes. So on top of EVs, we will have much more electricity demand at homes for heating, for cooking, for everything else. So EVs are just one more.
Yeah.
Thanks for the presentation. I really enjoyed that. And especially, I think the research on the EV adoption and infrastructure, that is really interesting. So my question is, because you said that actually the people's engagement is important in the visibility of infrastructure. So I'm wondering, how do you define the engagement here? You mean, you know, the EV knowledge level or their intentions? So how do you define that?
I think we take like several metrics. So if they can name an electric vehicle, if they can correctly identify how it's fueled, and if they have like positive sort of attitudes towards them, we sort of collectively see that as like engagement. And in addition to, if they know incentives exist and know like the existence of different programs. So we take the knowledge, the awareness, and the perception and measure of those to be like engagement.
Your understanding, your opinions, how do you think, you know, what ways they encourage them to engage more?
Yeah, that's a good question. I feel like that's the next step of this research. Like, what is engaging people? And we've asked that in interviews, like, how did you originally find out about electric vehicles? Like, what happened for you to get to this point? And most commonly, it seems to be through word of mouth. So they're finding out through colleagues, friends, or family. And then after word of mouth, the next most common was like people finding out through like the media, but in like quite specific areas of media that they follow. So like they're interested in cars anyway, they found out on a car website. They're interested in technology, they found out through a technology website. But I think the biggest one that we saw was through word of mouth, at work, at home, and with the family members.
And we think that the most important part of behavior, I don't know if the most important, is stocking the shelf. So it doesn't matter how many advertisements you do, but if the dealers doesn't have these cars, than the awareness remote cars. So if you want the awareness and the market to grow, you need to stock the shelf. You need not just to advertise, but to have this electric car in all colors, in all models, so people can buy the one they want. And then this network is working out this trust network. So it's not the expert network. You're not looking for an expert. You're looking for someone you trust. Your cousin, your friend from work said, "Oh, I'm driving one, it's great." And that's something that we need to help with this policy.
I think that also confirms with our research in Shanghai, which is submitted revision, right?
Yes.
Where we're looking at the effect of the peer effect, and then try to identify whether there is a tipping point in this peer effect, so that after a certain point, it's self-perpetuating sort of cycle begins. And in our empirical research, we do find there's a sort of tipping point between 31 to 40, somewhere around that range. So after that, a self-perpetuating cycle kicks in just through the peer effect sort of, influence.
31 to 40 years old.
Oh, no, it's the percentage of, percentage of,
Yeah, I agree. And people in California talk about this tipping point too. And they're saying like 25% sales, we're at the tipping point. And we're like, no, like 4% of people have a car. There's no tipping point yet. I would, I think that makes a lot of sense.
Yeah, ours was 31, and then we would say it's 31 between 40 because it's not, the questionnaire is not down to the point, it's brackets.
Right. So then in that case, like only Norway is approaching that, and nowhere everywhere else in the world is miles away.
So a great question in terms of analyzing and validating these causal links. But I guess this direct link that you try to analyze in terms of you see a charging station, you better decide or not. But there's a cumulative effect in terms of over time when you see these new developments and you may raise the question, what's happening, what's going on. So do you think that would be something that?
Yeah, so it's just a cross-section study.
Yeah.
It's unfortunately just a study at one point in time. And so like we don't know, like, a lot of these people, maybe they will go to see it, but we haven't been able to track that yet.
Frank?
It's somewhat like a question. I'm wondering if you're having useful information given in that survey in the attitude of people who are wealthy enough to have chargers at home versus those who don't have chargers. It's going to be very different in terms of how they react to the presence of people.
Definitely, yeah. Actually, I did talk about this, but so public charging wasn't really correlated with like consideration or seeing, but home charging was. So we did see that if you have a home charger, you have a higher odds of considering buying an electric vehicle. So I mean, we see it in every single research project we do on charging, and if home charging is included, it's always important for like the decision to buy an EV. Charging behavior is the most frequently used. We know that when people go to the decision to replace their electric vehicle, it's important to have home charging to continue choosing an electric vehicle. So yeah, like I don't think home charging is very cool. It's much more cool to look at like a $100,000 fast charger and like let's do those. But home charging is like, I feel like there's a lot of bang for your buck there.
Three hands, very quickly, and
There's more of a comment. I think there's a role for the EV driver associations. The Plug-in Americans, when we have in Australia, the Norway EV Association, which has 120,000 members, and we'll be workshopping with them in a couple of weeks' time coming up from Norway. But we run a lot of EV experience days where we have about 20 different EV models, and we talk to members of the public and offer passenger rides, and which are long conversations with them. And a lot of them appreciate the fact that we're not dealers, so that we can talk honestly about the shortcomings of the cars as well as how great they are. And so I think that's, you mentioned sort of word of mouth and family and members and friends, but I think there's a role for those associations to help raise community consumer awareness and perhaps get some facts across to people.
I definitely agree. And I think that's most important as well for people who are like in the engaged state, because that can push them over the edge to buy the car. I do think that like the people who don't know are less likely to go to those events, right? They're just going to walk past you. But I do think it's extremely important for those who are like already thinking about it.
So I guess two questions, one shorter. Did you have much visibility in, were they generally all in fairly dense urban areas where they would meet their driving needs? Was there any variation to that survey? And the other one was in terms of people seeing the chargers, did you have a sense of where they were seeing them? Like if they were seeing them at their workplace, then you didn't actually see any effect. But I do wonder if you were able to collect that, if you might see workplace make more of a difference than others, because you can leave your car parked there, you're walking out to every day, and that kind of thing.
Yeah, we I don't remember. There was one finding that was kind of interesting that we didn't see. We did see an effect of when the vehicle, like having lots of vehicles registered, then the presence of infrastructure was related to seeing it, which sort of made us think, well, okay, if there's a car being plugged in and someone sees that, like maybe your colleague folks in the car, you're like, well, what's going on there? That's kind of weird. Right? If you see that situation occur, then maybe it helps. But we didn't break it down. Maybe the first question you had.
On a different study, we've seen this neighborhood effect. So yeah, if you have many cars plugged in, it's a little bit better visibility than just drivers. And
The other question is about people if they can own a motor vehicle, like based on like usability, how far they go travel.
So it's interesting to see that today in California, most people can own no problem. Their daily drive is not an issue. We still have the problem with the vehicle type. So if you need a truck, it's always also a kind of a question: do you actually need a truck? But if you think that you need a truck, we don't always have the one for you. So it's more about the vehicle types than we give people the ability and daily driving.
Last question.
I'll do the brainstorm a much broader question. Is your institute looking at all at rebound effects? I'm just sort of wondering whether the lower cost of actually running an EV once you've got one, or even a bit of a guilt effect, as in, oh, I'm driving an EV, I'm not causing pollution, is going to lead to more vehicle ownership and use, and then you think about another infrastructure, which is road space.
Quite a lot, quite a lot. So yeah, it's always an important question. So in California, we probably have so many cars. You know, we have more cars than drivers. We are up to here. We drive anywhere we can, and it's hard to see a rebound effect in California on lowering the cost of driving. Unfortunately, it's not a good thing. But other countries, I think that we still are going to see a rebound effect. We have a couple of studies that show that even with the rebound effect, we have a net benefit of moving to electric transportation. But I think that there was a study that Scott was leading recently, kind of, that was not you asked about, but I will give it anyway, that autonomous vehicle, even the semi-automated, all of this kind of driving help that the Tesla have, create thousands of more kilometers a year. That people drive much more because it's much easier to jump to the car and drive to Sydney if you just put it on autopilot and you can, you know, relax for 3 hours. So we still have all kind of rebound effects coming at us from different angles.
Just to add to that, there's been a lot of studies on rebound effects for petrol cars. Yeah. And higher fuel efficiency. Honestly, they just can't get to a consensus on fuel pricing and a much bigger impact on kind of annual mileage than fuel economy of vehicles. And it seems like it's really non-linear, like it's bathtub, it's like extreme, like it's so cheap or so expensive that it really matters. They don't, it just changes how much people play about it. But there's been a lot less study focused on that dynamic the same. You know, it is, I think there is less connection between the consumer and what they're paying. They're not going to a fuel station and paying right there at home. You know, when they plug in and they get a monthly bill, their electric bill, you know, it's a less direct connection. You know, so I think it's different. I think the requirement study is more likely to figure out how that works. I mean, the early EVs, range is limited. You want to do a lot more miles than you really could. As Gil said, in California, people are already fed up with how much money they spend on the road. in traffic, and the last thing you want to do is hit a car and drive forward. But that's not the case.
And we can study it for you.
So on that note, thank you so much, Gil, Scott, and Alan, for your wonderful presentation. I mean, we really enjoyed this fruitful discussion. Thank you.